Well, hello everyone. Believe it or not, they're in their crate. Lay down. Probably the mailman. All right, I'm going to wait just a little bit longer before we get started so that I can see who we have and who we don't have, and then we are going to introduce our next topic and go from there. Okay, so I'm going to wait just 30 more seconds and then I'm going to get started and we'll go from there. Hopefully we are all checking Google Classroom so that we know what we need to keep in mind as we move on with this chapter. Please say hi so I know who's with us. And, oh, spelled please. Oh, well. Okay, so as we get started, thanks, Beth. As we get started, I want to talk about what this section is going to do. And first and foremost, this time we're still going to be working with right triangles. That's enough.
I'm sorry.
That's okay. We're going to be working with right triangles. And we are going to solve for side lengths. And for the first time, we're actually going to be able to figure out angle measures. Before, unless it was special, we wouldn't have been able to figure out the angle measures, unless of course it was isosceles, our 45, 45, 90, or our 30, 60, 90. But this time we'll be able to figure out any angle measure, even ones with decimals, fractions, anything. The other thing that we are going to be able to recognize is you only need one given side length to find the rest. Now, before with the Pythagorean theorem, you needed two sides. Before with our special rights, we needed, hi Jenna, with our special rights, we needed a formula and we needed to know one side length, but it fit a specific formula. So with that being said, our trig ratios are going to help us get away from that. We will be able to find everything that we need with these trig ratios. Now, the other thing that we're going to want to look for as we go through this, to start, we're going to have to remember and locate a couple things. We're going to have to remember the definitions of our trig ratios, so we don't write out trigonometry or what's called trigonometric, it's a tongue twister, trigonometric ratios. You will just be told trig ratios. And I'm not going to just leave it at this, but I am going to write them down very quickly here. Our first one is called sine, even though it looks like sin, it's an abbreviation of some angle. So we're actually going to just call it angle A. Notice it's a capital letter. And a very quick way to remember it, you're going to see a ratio opposite over hypotenuse. We're going to have another trig ratio, cosine of an angle, and that is adjacent over hypotenuse. And we're going to have a third, which is opposite over adjacent. So again, this is just an overview. We're going to go through this in depth. But that's the first thing that we're going to want to make sure is that we do master the definitions. In order to master the definitions, we're going to have to be able to identify opposite, adjacent, and hypotenuse in a right triangle. And the opposite and adjacent are only determined by which angle we are using. And the hypotenuse never changes. It is always opposite the 90-degree right angle. So that hasn't changed. So in order for us to do all of this, we are going to have this part memorized, which means in order for us to know what's opposite, adjacent, and hypotenuse, we're going to have to be able to locate those. And so that's where we've got to start. So that's what we're going to talk about today. After today, so later, we will use these trig ratios and equations to solve for sides and angle measures. So again, it's all part of our right triangle chapter. There's just a lot that goes with this, and we need to make sure, because it is new material, that we're paying attention to. There's important steps here. Without a doubt, because nothing in the real world is perfect values every time, this is big time real world application stuff. And depending upon how this goes, I may actually try to get you outside when it's not winter anymore, of course, get you outside and try some of this. So when all is said and done, I may have you measuring for the height of a tree and see how close you get. Or I'm looking at my backyard and I still have a play set sitting up in my backyard. So I could actually try to figure out how tall that play set is and then actually physically measure it and see how close I got. So this is big time world application. I know my cousin actually is an engineer, and he works for a company that builds bridges, and not just, a little one over a creek bed, but we're talking about over highways and from office building to office building type bridges. So there's a lot of what we're talking about in here that he uses on a daily basis. So this is where we start to transition from what we still may look at as pulling from elementary school type math concepts, and now finally bringing it all into something that later you will see used depending upon how far you choose to go after high school. So today, now that we've talked about what we're looking at, we're going to concentrate just on these two parts here. So with that, I know I only have a few of you with me, but I am going to draw a right triangle, and you can follow along with me. And I'm looking at Jenna's name, so we will use J, V, and D for our vertices. And the first question I want to ask is, and I want you to type the answers in if you could, please. I know I've got at least 3 of you with me, hopefully still with me. But type the answers in if you can. What side is opposite angle D? That's number 1. So if you know the answer to that, you can type number 1 and then give me what side. Remember, there's segments, so I need 2 letters. If you know this answer, what side is the hypotenuse? Put number 2 and give me that answer. So again, number 1, give me the example for what side is opposite angle D. And if you know the answer for number 2, what side is the hypotenuse, give me that answer. Anybody have their answers for that? Thank you. Let's take a look. Jenna is correct. We have JV should be opposite angle D. Again, one of the good things is with opposites, it shouldn't have the same letter as the angle we're talking about. So you are absolutely correct. Segment JV is opposite angle D. And you are correct too, Beth. Thank you. JD is the hypotenuse. So I'm going to then ask this third question, and it's what side intersects with the hypotenuse to make angle D, which obviously then narrows our choices down, but it's a good way to look at kind of the next word that we're trying to bring in here. So what side intersects with the hypotenuse to make angle D? And again, if you know, you can type that in. Very good. We do have line segment VD, and it kind of is a process of elimination. If we can already identify where the hypotenuse is, and we can already see what side is opposite, meaning it doesn't have the same letter as the angle we're talking about, the only one left is this guy here, VD. So notice that this one I specifically called opposite, and I specifically called this one hypotenuse, but I didn't yet use this one's correct name. I described it. It's the side that intersects with the hypotenuse to make the angle we're talking about. That guy's name is the adjacent side. And so if I would have asked what side is adjacent to angle D, then you would have told me that same, that same answer. So what side is adjacent, meaning right next to angle D? And you would have told me the same thing. That's our answer for that problem. So in order for us to know truly what adjacent means, it's the one that's next to the hypotenuse. So let's look at this question. That's our first way to ask this. Let's look at it again. We're just going to change the phrasing behind it. I'm going to move our triangle a little bit. I said I really want us to master how to name these before we start using them. But I wanted you to know right away why we're doing all of this. If it wasn't for knowing what opposite, adjacent, and hypotenuse ended up being, I couldn't do this. So E, D, and we'll have a shout out to Matt. So here is our triangle, our right triangle. And now I'm going to change these questions, and I'm going to say, according to angle E, name the opposite side, the adjacent side, and the hypotenuse. So for each of those, that's what we're looking to do. So this could kind of be like number 1, number 2, and number 3. So if you have those answers, type those in, and we'll see where we're at. I'm going to give you just about 25 seconds. I know that's some dead air on your side because of the delay, but I'm going to give 25 seconds for you to tell me what 1, 2, and 3 are. All right, not seeing anything, not knowing if we're still waiting. So I'm going to start filling in. If I look at where angle E is, and we're using the same process as before, one of my strategies could be, oh, there we are. There's the delay. See, I knew 25 seconds, 24 seconds. It would just depend. You're absolutely correct. Let's take a look. If we're at angle E, so now look at kind of the strategy I'm using here. I'm circling angle E. When I go across from it, you are correct. MD should be the opposite side. Our adjacent side should include the letter E, so we would have ED, and our hypotenuse is always opposite the right angle, and that is EM or ME, the way the two of you typed it in, so that's absolutely correct. Well done. Now notice something here. I circled this, and you'll notice that when I do problems later, not necessarily today, but on Wednesday, I still do this whole circle thing, just like I did with the special right triangles. Inside my circle, I've already identified the hypotenuse. So a lot of times you'll see me do that, and I will label HYP immediately on the hypotenuse. The other segment is always the adjacent. So when I circle the angle, you're going to see that inside here is always the hypotenuse and the adjacent side, which then leaves opposite all by itself. Again, the hypotenuse and the adjacent side should have the letter of the angle we're talking about. The opposite side doesn't include that letter, so that makes it a little easier to look at. All right, last one before we move forward. What we're going to do now is we're going to talk about our ratios. So now when we talk about our ratios, your calculator is set up all the time. I'm going to divide this because I said opposite, adjacent, hypotenuse are very important. But our calculators are set up specifically so that we always know what operation undoes each other. So let's just do a quick review here. First, on my calculator, it's going to be really hard to see here, but there's this little thing down here that a lot of you have this kind of calculator. And at the bottom here, you'll see that it should say DEG. Now, if it doesn't, what's nice is your calculator has this button right here, DRG. And if you push that button, you'll see at the top, DEG, which is degree, RAD, which is for radians. It's something to do with circles. And this guy right here, GRD, that has something to do with physics. And I'm not sure if I ever used that mode, M-O-D-E, that mode, because I have to switch sometimes the calculator between these modes. These two I've always used, and you'll see this in Algebra 2, but for right now in geometry, this is the only one you need. So if this doesn't say DEG at the bottom, the first thing you need to do is make sure that you push this button right here. Make sure that you arrow. Notice if you arrow, you'll arrow through and it'll underline it. Once DEG is underlined, push enter and it'll disappear, but down here changes to DEG. If for some reason you don't have, and there's those snots, those two little snots. If you don't have that, but you have this guy, if you turn it this way, you'll see that you end up with your scientific calculator. Now, I don't see any of those PRB buttons, but down here you can see there's an RAD. We don't want that. So if I touch that, it says DEG, but notice what popped up here? I don't want it in RAD mode. So when I push down here, it goes away. That means my calculator is in degree mode. So make sure that you don't put it with the RAD there. You have to take that off. And then it's in degree mode on your phone. Make sure that if you're using your computer, that your computer scientific calculator can also toggle between. So just keep those things in mind. So what's nice on our calculators is we have that button. That'll change it to degree. And then notice your calculator has these three buttons, and you already kind of saw in my overview these three buttons, those words showed up. And it's, again, not sin, not cos, and not a color tan. It's sine, cosine, and tangent. Those are abbreviations. Now, our calculator does a nice part of always organizing our information. Multiplication and division undo each other. They're inverse operations. Addition and subtraction undo each other. Those are inverse operations. Over here, this x squared, well, we know when we undo something squared, right above it is the square root. You'll even see later that the caret raises things to the third power, the fourth power, but even that guy, the second power, right between our pi button and the caret, that undoes, that takes the third root of something, the fourth root of something. So even these guys above, sine, cosine, and tangent, they're going to come in handy. So kind of recognize where everything is on your calculator. So in order to even use our calculator, the first thing that we want to talk about is what our definitions are. And that's our trig ratios. So we do have sine, and that's it spelled out. However, it is always abbreviated SIN. And directly next to the abbreviation for sine will always be an angle measure. Now, before I use the letter A, let's use the letter B here. And then we're going to have a ratio. Opposite side length of angle B over the hypotenuse length. And it is a fraction. But notice up here I specified that if I'm using angle B here, the opposite side is in relationship to angle B, the same way we did these examples up there. Cosine, when we look at our right triangle, will be abbreviated COS. Always next to it is our angle, and then it will have a fraction, the adjacent side length, again, of the angle we're talking about. So in this case, angle B, and it will be divided by or over the hypotenuse length. And last is not the color tan, but it's called tangent. And its abbreviation is TAN with our capital B for the angle we're talking about. And this time it's our opposite side length, still of angle B, so we're going to reuse numbers, and our adjacent side length of angle B. Now, of course, this is pretty lengthy. And you're never going to write out all of this. So when we look at our abbreviation that I said earlier, our abbreviation is going to look like, sorry, I got carried away there. Sine B is opposite over hypotenuse. Cosine B is adjacent over hypotenuse. And tangent B is opposite over adjacent. Those are the abbreviations. Makes it a lot easier than writing out all of this. and there is a mnemonic device, a way to remember things, and it's SOHCAHTOA. SOHCAHTOA. And you very well may have already heard this before, but the S, that stands for sign. The O stands for opposite. And the H stands for hypotenuse. Notice sine is opposite over hypotenuse. So sine opposite hypotenuse. So then you can probably guess that the C here stands for cosine. That the A stands for adjacent. And the H again stands for hypotenuse. And I have been doing this, weirdly enough, since the 8th grade. And I say weird because when I was in the 8th grade, I was still taking sprint math tests, where you would see how many of the 50 questions you could get right in 2 minutes. So the fact that we were even talking about trig, I think, is interesting. But since that day I learned it in the 8th grade, I still say this every time I do every problem. So right now, when I was writing out all the definitions, my brain automatically said SOHCAHTOA so that I didn't make a mistake. And it happens every time, especially with tangents, so I know to put the opposite over the adjacent. This is the easiest way to memorize those three. So I want to write the ratios. So we're going to give an example of what that looks like, and then we're done for the day. So we're going to write all the trig ratios for the acute angles. And I'm giving you this right triangle. And I'm going to tell you that this is W, X, Y. Not very creative this time. And this is going to be 6, 8, and 10. Well, the first thing I have to pay attention to is that it says all of them, so that means I'm doing more than one. So all, more than one, folks. And that happens too many times where I'll give a question and I get one answer. It says all, so there has to be more than one. We want a ratio. So this is, we want a fraction. And we want to make sure that we reduce. At no point in time do ratios ever get left like 5/10 or 18/24. We always reduce ratios. And the last thing that I need to make sure is that I know which ones are the acute angles. If I don't know which ones the acute angles are, I can't do this. So I need to make sure that if that's the right angle, this guy is an acute angle, and this guy, Y, is an acute angle. So those are the two that I'm talking about. So I need to start with one of them, and I'm going to show you, just like I did before with our special rights, how I do this. And I do color code them. I'm going to start with angle W, because it's up top and it's first in the alphabet, and I'm going to circle it. And according to angle W, the perspective that I'm sitting up here at angle W, I have my hypotenuse, the adjacent side, and down here is my opposite side. So when I write the trig ratios according to angle W, the first trig ratio is sine. So I do sine and then the angle, now it's W because I don't have a number here. And then I write opposite, so I look to see here, opposite side length is 6, and the hypotenuse length is 10. It's a ratio, so I need to reduce, so I write 3/5. We're going to do cosine, because that's the next trig ratio, still at that acute angle. And it's adjacent, so our adjacent side length is 8, and our hypotenuse is 10. And again, it's a ratio, so I reduce. And the last trig ratio is tangent, again, of the angle I'm talking about. And then the opposite over adjacent lengths, and again, we reduce. Now that was angle W. All the trig ratios, and we have plural the acute angles. So I need to make sure that I deal with both angles. So now I'm going to be down here at angle Y. And I'm going to do the same thing. Notice I changed colors. And I'm going to label according now to angle Y. Well, the hypotenuse will never change because that's opposite the right angle. But what side is now adjacent to angle Y? That's this guy. And what side is opposite angle Y is now 8. So I'm going to start again. Sine of Y equals opposite over hypotenuse, and we reduce. Cosine Y, that's now adjacent over hypotenuse, and we reduce. Tangent Y, and that's opposite over adjacent, and we reduce. And we have to, how do you know to use W? So what we have to do is, because it says the acute angles, that's why I have to use these two. I will never use the right angle. And someone always asks, well, why not? And I said, because there is no difference between the adjacent sides. One isn't better than the other. Not to mention, opposite already has a name, hypotenuse. So when it says we're doing any of the trig functions, it's got to be one of these two. Because this question says all, I did all 3 from angle W, and then I'm doing all 3 from angle Y. So I want to make sure that I'm doing all the trig ratios of the acute angles, and because there's 2 of them, I picked 2 of them. I'm not solving for anything at this point. I don't care what the angle measures are at this point. This is step 1, where we just get comfortable with setting up the ratios. So again, this part is just step 1, getting comfortable with the ratios. So it was an acute angle, write them out for both acute angles, all of them. And that's what we did. Okay? So now, just because we had that question, I'm going to do this guy. And we're going to change the question a little bit. If cosine of angle W Siona's here, so we'll give her a shout out. Angle W equals 8/17. Find the other trig ratios for angle W and angle V. And I'm going to draw our triangle this time. And we have angle W, and it doesn't matter where I put W. I just can't have it at the right angle. So when I'm drawing this myself, I know I'm making up the question, but again, I cannot do any trig ratio for the 90-degree angle. It has to be specifically for the acute angles. So I couldn't put that there, or else I can't do this problem. So I had to put W at one of these two vertices. So whether it's here or here doesn't matter. What matters is where I place these two numbers. Again, W didn't matter where it went, neither did V. It just had to be one of these two, could not go here. So the problem said that cosine of angle W was 8/17. I know that the definition is adjacent over hypotenuse. That's the definition. So if I'm up here at angle W, I know, and it doesn't matter what the picture looks like. I just have to put these in the right spot. I know that this side is my adjacent side. This side is my hypotenuse, which makes this guy opposite. So if I was to put these two numbers into my picture, this side has to be 8, because that's what this ratio is telling me. And this guy has to be 17, because that's what the ratio told me. Adjacent over hypotenuse, adjacent and hypotenuse. Which means I got to figure out what this last side is in order for me to find the other trig ratios. Well, what have we always used with right triangles? To find the third side, use Old Faithful. Use our Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. I'm going to let you in on a little secret. This is a Pythagorean triple. And a lot of times you're going to see that happen because it's just easy to put the problem together using 3, 4, 5 or 5, 12, 13. In this case, this is 8, 15, 17. And you can kind of see that's kind of where my mistake came from here. My brain was already 15 steps ahead of where it should have been. This is an 8, 15, 17 triple. So back here, whether I use the Pythagorean theorem or remember that it's a triple, I now know that this guy is 15. Saves a lot of time if I know that. So if I want to finish here, sine W is opposite over hypotenuse. There's no way to simplify, so we're done. And tangent W is opposite over adjacent. And it's a ratio, so you leave it as is. We don't make mixed numbers for ratios. When I want to change vertices so that I can do the other angle, angle V, hypotenuse won't change, but adjacent and opposite will. So then we start over. Sine V is opposite over hypotenuse. Cosine V is adjacent. Oops, dang it, Angie. Yes, you can get mad. I was all ready for that 15 again. Opposite over hypotenuse. Adjacent over hypotenuse. And tangent V is opposite over adjacent. That's it for today. What you're going to see is I'm going to put these notes in Google Classroom, and I'm going to give you 2 practice problems. The first one is going to look just like this, where I'm going to give you everything, and you're going to write out the trig ratios for both acute angles. And then I'm going to give you one just like this, where I'm going to tell you what the trig ratio is, and then either using the Pythagorean theorem or maybe it's a triple, you're going to use that to plug in that missing piece and then write the rest of them. So that's going to be the practice for this evening. I'm not going to go any further today. Just know that you've already seen this does go further, and we're going to now use these, notice the equal sign, we're going to use these equations to find the missing piece. Right now we've got just ratios. Wednesday we're going to go ahead and look at how to use the ratios now that we've practiced that. I do suggest that if need be, you rewatch. I am going to load to your classroom the honors geometry notes. If for some reason you want to watch their class, you can go to YouTube and watch their class. I went a little bit further with them. So if you want to jumpstart, you can go there. Otherwise, today this is where we're going to stop, and I'm going to give you a couple questions, 2 questions, just to practice. I really do appreciate, there's 5 of us here now, so yay, we've gained a person. But please make sure that you are paying attention and following along, and check Google Classroom for the information, and I appreciate you guys. Thank you so very much. Beth, tell your brother I said hey.